how many positive integers less than 60 have an even number of positive divisors? Now first, we have to understand the problem, very, very important. And this divisors, it actually isn't anything like so fancy or anything. This isn't very fancy because divisors means factors. For example, if they want all the divisors of 6, well, we know 6 is divisible by 1, 2, 3, and 6. But we also know that 1, 2, 3, and 6 are all factors of 6. So for a number to be a divisor of another number, then it also has to be a factor of that same number. So we know that's true. So now we understand the not exactly very fancy part. Let's play around with the problem a little bit. We're going to try some numbers. We're going to try to list all the factors. We're going to try to list the factors of all the numbers from 1 to 5. We'll start with 1. Well, 1 is pretty easy. That's just 1 times 1. 1, we have an odd number of factors. That's our only factor. Now we try 2. Well, 2 is prime, and we just have 1 times 2. That's also pretty easy. Same, we have 1 and 2. That's an even number of factors. And 3 is not very interesting either. We just have 1 and 3. Even number of factors as well. But 4 is a little special because if I take a look at the factors of 4, I see 1 and 4 and 2 times 2. I see 2 pairs. But when I circle 1 and 4, we don't want to circle both of these. Only one of these is a factor. I can't say both of these is a factor because these are the same numbers. Now let's take a look at 5. See if that has an even number of integers. Even number of factors. Or odd, that is. 5 is also prime. It does have 2 factors. But look at what we have here. Numbers that have an odd number of factors are 1 and 4. What's so special about 1 and 4? They're the perfect squares. But let's just work with all perfect squares. Is it like all perfect squares have an odd number of factors and all the numbers that aren't perfect squares have an even number of factors? Well, let's check that out. So let me think. If we have a number, well, the factors of that number, like a number, the factors of it is always something times something. We can't have like blank times blank times blank. It's not 3 numbers, it's just 2. So we're going to keep going like this. They're just pairs, 2, 2, 2, 2, 2, until we get to a number that's something like a times a. Well, a times a, only one of these is a factor of whatever number we're trying to find. Because we can't say, well, 2 and 2 is a factor of 4. That's pretty confusing. Only 2 is a factor of 4. We should say 2 is a factor of 4 instead of 2 and 2 is a factor of 4. So we know any number, so now we know any number that's not a perfect square isn't going to have a times a in their factors list. So they're just going to have pairs, 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 pairs. That's all it's going to have, which means any number that that isn't a perfect square has an even number of divisors. But any number that is a perfect square has an odd number of divisors because it does have this a times a thing in it. So now we just have to count the number. We just have to count the number of perfect squares from 1 to 60. Well, that's pretty easy. 1 and 4, 9, 16. All of these have an odd number of divisors. 25, 36, and on, 49. Well, we're not 7 squared. 8 squared is 64. That's too large. But here's the thing. Don't be like, you did all this work, but then you get the answer wrong. The simple part. You don't want 60 minus our 7 numbers. We want 59 because they want less than 60. This doesn't include the number 60. Okay, got that? Not 60. So we have 59 minus 7, which is 52 numbers that have 52 numbers less than 60 that have an even number of positive divisors.